My name is Antonio Ramirez. I'm a professor at The Ohio State University, and I've been leading this Welding in Space program at the university for the last 4 or 5 years.
We are basically the only ones applying high-speed videos where we can replicate temperature change, vacuum, and also gravity to simulate the space condition.
The core objective is trying to decipher the changes that could happen during laser welding in space conditions.
Because especially for welding in space, you have to have a defect-free weld and you have to have no spatter.
It's about building very large structures in space. We are about to start colonizing the moon. We are launching a nuclear reactor by 2030, so it's much easier. Ship the parts, unfold some of them maybe, but put it together on space. We really need welders there.
With pulse laser welding, the laser is only on for a very small amount of time, which allows us to have higher peak power. And when we weld on that, the material liquefies and solidifies incredibly quickly.
With the Phantom camera, what we're observing is how the weld pool is evolving throughout the entire weld.
Allow us to look at phenomena that happen in microseconds or even fractions of that.
You can see a process that no one really is able to see just perfectly, like crisp and clear.
Without these cameras, we can't see what's happening, and then we can't change the process to make it a better weld. These types of videos really excite that new generation. When they can see all the complex things happening, they can see how all the math and science they're learning is applied, and the really fun stuff you get to do.
Every single engineer has one time of dream working for NASA and working on space exploration, right? And I'm no exception for me. Now I realize that actually that dream is coming true. I actually put in my little piece to make sure we develop technology that is going to enable NASA and humanity as a whole to actually explore space on a more safer and sustainable way.